My name is Neelasetti Venkat Sai Sarath. I am studying in AANM and VVRSR Polytechnic, Gudloleru. My pin 180303109. I am writing a new programming on maximum power transfer theorem. To write a program, you have to go to the files. I am writing this program in MATLAB. Open a new file, and I am creating it on maximum power transfer. Create it. In this theorem, the amount of power received by a load is an important parameter in electrical and electronic applications. In electrical engineering, the maximum power transfer theorem states that to obtain maximum external power from a source with a finite internal resistance, the resistance of the load must be equal to the resistance of the source. I am saying another time, the resistance of the load must be equal to the resistance of the source as viewed from output terminals. So, okay, I am applying an external voltage of V is equal to 10 volts and the source resistance Rs is taking as 4 ohms. Going to the next step, I am going to do this program by using a for loop. I am taking I is equal to I is equal to 1:41. Why here I am taking I is equal to 41? I will say in the next step. In third step, load resistance RL. Here we are taking condition of RL is RL of I and close the bracket is equal to I into 0.1 minus 0.1. Put the column. In this step, take I as 41 and multiply with 0.1. By multiplying 41 into 0.1, we get 4.1. Then 4.1 minus 0.1, we get 4. That means the load resistance, we get the 4. That means the load resistance can be vary up to 4 ohms. In this theorem, power can be obtained by next step. Power can be obtained by V Thevenin by R Thevenin. That means in general P is equal to I square R. I square means I into I. In general, we can take I as V by R. Here in this formula, P is equal to I square. So we have to write V by R into V by R into R. That means in this substituting the formula P of I, have to substitute the formula carefully because it is lengthy but easy by understanding the formula. Is equal to, open the bracket. In I square, we first substituting 1I, that means V by R, taking V by open the bracket, load resistance R L of I and adding source resistance also. Resistance means here load resistance plus source resistance. So we are adding source resistance also, Rs, and close the bracket. We have to carefully check the brackets while we are closing one time or two time, and multiply with another V by R. Taking open the bracket, we have kept numerator as V and denominator. Two types of resistance are adding, that are load resistance and source resistance, by open the bracket, RL of I plus source resistance RS, and close the bracket 2 times, and we are multiplying R also. Power means I square R. We kept instead of I square V by R into V by R. We have resistance also, another resistance. So resistance, load resistance of R of I, RL of I into RL of I give column. By these steps, the maximum power transfer theorem is completed. And going to the next step in this program, but we have to plot the graph between load resistance and power. That means plot graph between load resistance and increasing of current RL and close the bracket. I am executing this program. By executing this program, so by giving a source resistance of 4, we have get this graph. This is the graph for by giving the external voltage of 12 and source resistance 2, and we get the you get the source resistance of 4 by giving the load resistance as 4. So in this graph, maximum is at 4. So the maximum power transfer at the resistance of 4. That means load resistance is equal to the source resistance. When the load resistance is equal to the source resistance, the maximum power will transfer. So this is the graph to say about the maximum power transfer theorem. Thank you.